In this session, we're going to look at what happens when you take the derivative of e to the x or ln x. So you might want to try this as well. If you take your calculator out and just plot or graph fx equals e to the x. So if this is our function, how can we find the gradient? Well, one of the ways we can do this is by using our calculator to find dy by dx. So on your calculator, you can use the gradient function or from the derivative to see that the gradient function here in red is actually exactly the same as the function. So this is a special case where the gradient of this function is actually the same as that function. Now, just to think about what that means, if we have a look back at the initial function here, if I have e to the x and I've got some value here, e to the negative 5, what that means is 1 over e to the 5. So this number here is going to be very, very small. And you can see the gradient is very, very small. It's almost 0. As the values of x increase, we can see, for instance, here, if this is e squared, we can see that our value of y increases, but also we can see that the gradient at this point increases. So what we have here with e to the x is the special case where the derivative of the function is actually the function itself. So that's the first thing to note. The derivative of x, if we have fx equals to ex, the derivative f dash x also equals e to the x. The next special case we're going to look at then is the case of ln x. So again, on your calculators, you might just want to plot this and then use the derivative function on your calculators to find the gradient function. If you do that, you should end up with something like this, the red line here. Hopefully, you can make a connection to what we looked at in the previous unit of functions. And you can see that this is actually a reciprocal function. This is the graph of 1 over x. So if we have a look at the table of values, for instance, if this is x down here, 1 over 1 is 1, 1 over 2 is 0.5, all the way down. So we have our second special case here when we're looking at the derivative of ln x, which is the derivative of ln x, f dash x, equals 1 over x. So let's just have a look at a few questions to get to grips with that. So I suggest you pause the video now and just try these 3 quick questions. Question 1 then, f of x equals 3 e to the x. So we already know that the derivative of e to the x is e to the x, and then this is just the constant multiple rule, 3 times e to the x. So all we're going to do is just separate this up. This is going to be 3 times e to the x, which is also 3 times e to the x. Part B then, x squared plus ln x. So here we're using the rule that the derivative of ln x equals 1 over x, and we're using the sum or difference rule, which says we can just add the derivative of this to the derivative of this. So in that case, all we need to do is find the derivative of this, which is 2x, and the derivative of this, which is 1 over x, which gives us 2x plus 1 over x. And we could simplify that if we wanted to 2x squared plus 1 over x. The final function c equals ln e to the 3x. Well, here we should remember from the unit on logs that if we have ln of e to the 3x, in effect these cancel out and you're just left with 3x, which we can therefore differentiate to get 3.